Good morning everyone. Today, I am going to discuss with you Module 7 of Science 7 Quarter 4. And this is your Science 7 teacher, Sir Topper. And before anything else, let us pray. In the name of the Father, and of the Son, the Holy Spirit. Amen. Panimulang panalangin.
Panginoon, salamat po sa panibagong araw na ito upang kami ay matuto. Buksan niyo po ang aming isipan upang lubos na maintindihan ang aming mga aralin. Bigyan niyo din po ang aming mga guro, mga magulang, at mga kamag-aral ng lakas ng katawan at isipan na mas higit naming kailangan sa araw-araw sa panahong ito. Ang lahat po ng ito ay aming dinadalangin sa iyo, aming Diyos Ama. Amen.
Amen. Okay, so how I'm feeling right now. So place a dot on the column or columns that show your feelings at the moment. Are you angry? Are you happy? Nervous or sad? So thank you very much for doing that. Let's proceed. What I need to know. Hello kids, how are you doing today? You probably noticed longer nights than daytime in the summer, or longer daylight than nights in the summer. While the occurrence of the day and nights is due to the Earth's rotation around its axis, what do you think causes this variation in day and night on Earth? In our previous grade, you tracked the weather for the whole year round. You found out that there are two seasons in the Philippines, the rainy and the dry, or the wet and dry. You might have noticed, too, that there are months of the year when it is cold and months when it is hot. The seasons follow each other regularly, and you can tell in advance when it is going to be warm or cold, and when it is going to be rainy or not. But can you explain why there are seasons at all? Do you know why seasons change? In this module, you will learn the position of Earth in its orbit and its characteristics around the Sun. Most essential learning competency for this module, Module 7 of Science 7, Quarter 4. Using models, relate the position of Earth in its orbit to the height of the Sun in the sky. After going through this module, you are expected to determine the characteristics of the Earth's orbit from the Sun, illustrate the Earth and its orbit at different times of the year, and explain the relationship of height of the Sun in the sky to the seasons. Let's move. And before the discussion or the lesson proper, let us have this one. What I know. Directions. Read and understand each item carefully. Choose your answer and key in your class point up. Number 1. What is the speed of the Earth's orbit around the Sun? Is it A, 100,000 km per hour? B, 109,000 km per hour? Or C, 110,000 km per hour? Or D, 111,000 km per hour? You're correct. It's letter A. It's 100,000 km per hour. Number 2. How many solar days the Earth completes one orbit? Is it A, 364.542199 solar days? B, 365.242199 solar days? C, 365.542199 solar days? Or D, 366 solar days? Very good. It's letter B. It's 365.242199 solar days. Let's proceed with question number 3. What do you call the point on Earth's orbit when the Earth is closest to the Sun? Is it A, aphelion? B, astronomical? C, orbital? Or D, perihelion? Very good. And that is perihelion, letter D. Number 4. What do you call the point on Earth's orbit when the Earth is at its farthest distance from the Sun? Is it A. Aphelion, B. Astronomical, C. Orbital, D. Perihelion? Correct. It's letter A. It's aphelion. Let's proceed with question number 5. What is the average distance of the Earth from the Sun? Is it A. 145.5 million kilometer, B. 147.6 million kilometer, C. 148.7 million kilometer, or D. 149.6 million kilometer? For number 5, it is 149.6 million kilometer, and that was letter D. Number 6 question. Rather than being perfect circle, the Earth moves around the Sun in an extended circular or oval pattern. This is known as A. Astronomical orbit, B. Elliptical orbit, C. Spherical orbit, or D. Circular orbit. You're correct. It is called a spherical orbit, and that is letter C. Number 7 question. What is the point in the orbit of maximum axial tilt toward or away from the Sun? Is it A. Aphelion, B. Equinoxes, C. Perihelion, and D. Solstices? Correct. This is letter D. Solstices. Number 8. When the direction of the tilt and the direction of the Sun are perpendicular, what do you call this phenomenon? Is it A. Vertical, B. Solstices, C. Axial, D. Equinoxes? Correct. It is solstices. Letter B. Let's proceed with question number 9. When the Northern Hemisphere is tilted away from the Sun, it experiences what season? Is it A. Fall, B. Spring, C. Summer, and D. Winter? And you're correct. It is winter. Letter D. Number 10 question. Consider the picture below. How would you describe the position of the Earth in its orbit around the Sun? A. The Earth rotates on its own axis. B. The Earth orbits the Sun in an elliptical manner. C. The Earth spins in a counterclockwise direction. And D. The Earth's axis is tilted with respect to the plane of the orbit. And you're correct. The Earth spins in a counterclockwise direction, and that is letter C. Number 11 question. Which of the following is true about the characteristics of Earth's orbit around the Sun? Is it 1. The planet travels 940 million kilometers during a single orbit. 2. The Earth's orbit around the Sun is 108,000 kilometers per hour. Or 3. The Earth completes 365.242199 solar days. Is it A. 1, 2, 3 only? B. 2, 3, and 4 only? C. 3 and 4 only? And D. All of the above, meaning 1, 2, 3, and 4. You're correct. It is letter B. Only 2, 3, and 4 for this problem. Let's proceed with question number 12. The planet's distance from the Sun also varies as it orbits. Which of the following statements is true? The Earth is never the same distance from the Sun from day to day. When the Earth is closest to the Sun, it is said to be at perihelion. 3. When the Earth is at its farthest distance, it is at aphelion. Is it A. 1, 2, 3 only? B. 1, 3, 4 only? C. 2, 3, 4 only? And D. 1, 2, 3, and 4. So number 12 is letter D. all of the above. Let's have number 13. Study the globes below. The globes, or the picture of the globes, are in our right side. The globes represent the Earth facing from the direction of the Sun. In photo A, the Northern Hemisphere is tilted toward the Sun. In photo B, the Northern Hemisphere is tilted away from the Sun. The Philippines is inside the black square. Which photo shows the Philippines during summer? Is it A, photo A, B, photo B, C, photo A and B, and D, neither A nor B? That's correct. It's letter A, photo A. And let's proceed with the next question. Question number 14. Study the figure below. The drawing shows how the Earth is oriented with respect to the Sun during the month of June. Which hemisphere receives direct rays from the Sun in June? For number 1, Northern Hemisphere. Number 2, Southern Hemisphere. Okay, letter A, 1 only. B, 2 only. C, 1 and 2. D, neither 1 nor 2. And the answer is 1 only. Letter A, only for Northern Hemisphere. For the last question, we have study the figure below. The drawing shows that the Earth is oriented with respect to the Sun during the month of December. Which hemisphere receives direct rays from the Sun in December? For 1, it's Northern Hemisphere. 2, Southern Hemisphere. Is it A, 1 only, B, 2 only, C, 1 and 3, and D, neither 1 nor 2? Okay, you're correct. It's only 2, and that is letter B. Congratulations for those who got it right. And for today, we're going to talk about this lesson. How far is the Sun in the sky? What's in? Hello learners, in the previous module, you learned that the day and night are due to the Earth's rotation on its axis. In other parts of the Earth, there are months when daytime is longer than nighttime, while there are also months when nighttime becomes longer than daytime. Amazingly, there are certain periods of the year when the length of daytime and nighttime is roughly the same. You probably already knew that the Earth also moves around the Sun as it moves about its own axis. What do you think is the result of this Earth's motion around the Sun? What causes the variations of the length of daytime and nighttime around the year round in some parts of the Earth? And let's try to find out in this module. There we go. What to do? Look at the pictures in column A, match it with the seasons in column B. So you may write your answer in this portion. Okay, let's reveal. For the first picture, we have summer. Second picture, that is fall and spring. Last picture is winter. What's new? Ever since the 16th century, when Nicholas Copernicus demonstrated that the Earth revolved around the Sun, scientists have worked tirelessly to understand the relationship in mathematical terms. If this bright celestial body, upon which depends the season, the diurnal cycle, and all life on Earth, does not revolve around us, then what exactly is the nature of the Earth's orbit around it? Have you ever seen a top spinning around and round? The Earth spins around in much the same way as a top does. The Earth spins around an imaginary line that runs through its center. This is called the axis. Every 24 hours, the Earth makes one complete spin or a rotation. The rotation of the Earth causes day and night. It is also important to remember that there is another imaginary line that divides the Earth around the middle into two halves, the Northern Hemisphere and the Southern Hemisphere. And this line is called the equator. The Earth's axis and the equator play a huge role in understanding about the seasons of the planet. Are you now interested in our lesson? I hope that you can apply your analytical skills in the activities that we will discuss in this module. So, let us start. Activity 1. The Earth and its latitude. So as you can see from the drawing, the first latitude is the Arctic Circle in a 66.5 degree north. The second one, below that Arctic Circle, is the Tropic of Cancer, located at 23.5 degrees north. And the next one, below it, is the equator. It is the 0 degree or latitude. The next one is located at 23.5 degrees south, and this is Tropic of Capricorn. And lastly, it's located 66.5 degrees south, and it is called Antarctic Circle. And here are the questions. How do the sun's rays hit the Tropic of Cancer when the Earth is tilted toward the sun? Number 2 question. Will the sun rise and set in Arctic Circle when the Northern Hemisphere is facing away from the sun? Why or why not? What do you think is the answer? Anyway, let's proceed. What is it? The Earth moves around the sun in a path called an orbit. The movement of the Earth around the sun is called revolution. The Earth revolves around the sun at a speed of 108,000 kilometers per hour. This means that the planet travels 940 million kilometers during a single orbit. The Earth completes one orbit every 365 days and 6 hours and 8 minutes, approximately 365 and 1/4 days or 1 year. The remaining 1/4 day is added to the calendar after every 4 years, and the year with 366 days is called a leap year. Let's talk about the Earth's axis. The Earth's axis is tilted at 23.5 degrees from the vertical. As viewed above the North Pole, the Earth rotates counterclockwise, which explains why the sun appears to rise in the east and set in the west. So here is the figure. So as you can see, on the left part, it is the June or the summer solstice. On the right is the December or the winter solstice. And above is the equinox. This is the so-called vernal or spring equinox that happened during month of March and specific day 21 of March. And the lower part is the autumnal equinox that happens always September 23. The orientation of the Earth's axis remains fixed throughout the seasons. It points directly toward Polaris, the North Star. As a result of this fixed tilt, the Northern Hemisphere is tilted away from the sun in December and towards the sun in June. Meanwhile, the tilt of the Earth is neither towards nor away from the sun during March and September. So look at this. This is a picture of the axis tilt and the sun's height in the sky. So they have different months, they have different degrees and different heights. The fixed tilt of the Earth as it orbits the sun results in change in the observed height of the sun above the horizon. The sun appears to cross the higher path above the horizon in the summer and lower path in the winter. This means that the sun takes longer to cross the sky in the summer and shorter amount of time in the winter. During spring and fall, it traces an intermediate path. The sun's height is at the maximum when it is directly overhead at solar moon. The location on Earth where this occurs is called the subsolar point. The subsolar point occurs on the equator during the spring and fall equinoxes. On these periods, the subsolar point is over the equator with a sun angle of 90 degrees at solar noon. All the latitudes except the extreme poles in the northern and southern hemispheres are illuminated and receive roughly the same length of daylight and darkness, or nighttime. At each of these two equinoxes, the sun rises due east and sets due west. In figure 5, as you can see at the right, the maximum sun's altitude declines with latitude as one travels away from the equator. For each degree of latitude traveled, the maximum sun's altitude decreases by the same amount. The noon sun angle can be measured by subtracting the location's latitude from 90 degrees. And during the summer solstice, the subpolar point moves to the Tropic of Cancer, which is 23.5 degrees north. At the northern half of the Earth is angled towards the sun. On this day, the position of the sun in the sky at noon is at its highest altitude, or on its highest height. And the position of the sun at sunrise and sunset is the farthest north. All places above this latitude have maximum sun altitudes that are 23.5 degrees higher from the equinox positions. Places above the Arctic Circle, that was the extreme North Pole, are in 24 hours of daylight. Below the Tropic of Cancer, the noon angle of the sun decreases a degree in certain height for each degree of latitude. At the Antarctic Circle, the maximum sun's altitude becomes 0 degree, and locations lower than this point are in 24 hours of darkness. So this figure number 6, this is a picture during the summer solstice. The subpolar point is at 23.5 degrees north of the equator, which is located in the Tropic of Cancer. During the winter solstice, the subpolar point is located at the Tropic of Capricorn, and that is located 23.5 degrees south. When the South Pole is tilted 23.5 degrees towards the sun rises and sets farthest south. No light reaches above the Arctic Circle, which is 66.5 degrees north, and all locations below the Antarctic Circle, which is 66.5 degrees south latitude, experience 24 hours of sunlight. So figure 7, a winter solstice, a solar point is located at the Tropic of Capricorn at 23.5 degrees south when the South Pole is angled 23.5 degrees toward the sun. Let's talk about the Earth's orbit. The shape of the Earth's orbit also adds to the amazing characteristics of the planet. Rather than being a perfect circle, the Earth moves around the sun in an extended circular or oval pattern. This is what is known as an elliptical orbit. This orbital pattern was first described by Johannes Kepler, a German mathematician and astronomer. The shape of the Earth's orbit explains why there are periods of the year when the Earth is closest to and farthest from the sun. In fact, the Earth is never the same distance from the sun from day to day. When the Earth is closest to the sun, it is said to be at perihelion. This occurs around January 3rd each year, when the Earth is at a distance of about 147, 98, and 74,000 kilometers. When it is its farthest distance from the sun, the Earth is said to be at aphelion, which happens around July 4th, where the Earth reaches a distance of about 152,097 and 701,000 kilometers, which is also referred to as one astronomical unit, or AU. Although it varies, there is a little difference between the perihelion and aphelion, so the Earth's distance between the 2 points differ at less than 5 million kilometers. This small difference between the aphelion and perihelion is not enough to affect the seasons on Earth. So this is the illustration, aphelion and perihelion. So what's more? So study the picture above and answer the following questions on a separate sheet of paper. Assuming that the Earth intercepts at the same amount of energy from both rays A and B, which would receive more energy per unit area, and that is B, and which would you expect to be warmer? Same, letter B. How the Earth moves around the Sun. So, question, is the distance of Earth around the Sun the same as its orbits? Question 2, what do you call the point when the Earth is close to the Sun? Number 3, what do you call the point when the Earth is far from the Sun? Number 4, what causes the Earth to revolve around the Sun? So what I have learned, so we have this one. So directions, read the following questions carefully, answer it and separate sheet. So going to summarize the characteristic of Earth and its motion around the Sun in a table like the one below. The first characteristic is given as your guide. Okay, so let's have this concept map. Complete the concept map below. Use the words phrase inside the box as your choices. We have aphelion, summer, height of the noon sun in the sky, perihelion, the tilt of the Earth, or winter. So seasons are related to blank. Seasons are not directly related to, which are caused by, is the lowest during, is the highest during, varies due. Okay, so here are the answers. So what I've learned for number 1, the height of the noon sun in the sky. Aphelion 2, perihelion 3, and the tilt of the Earth is number 4, and 5 is winter, and number 6 is summer. What can I do? So, you're going to challenge yourself by answering these questions. How are the people's way of living influenced by the seasonal changes in the Earth? 2. How do you feel living in a place or country does not get to experience the true seasons? And 3. What do you think are the advantages and disadvantages in living near the equator? So you may have this answer. Okay? So let's have this assessment. So directions, read and understand each item carefully and choose your answer and key in our class point up. Number 1, what's the force that keeps the Earth from moving straight into space? Correct, it's gravity, letter B. Number 2, the Earth makes one blank every 24 hours. That is letter C, rotation. Number 3, the Earth makes one revolution around the Sun in about how many days? Approximately, it's 365 days, and that is letter C. Number 4, the Earth takes one blank to move around the Sun. 1 year, that's letter D. What is an imaginary line through the center of the Earth around which the Earth rotates? Correct, it's axis, letter A. Number 6, what do you call the point on Earth's orbit when the Earth is closest to the Sun? Correct, it's perihelion, that's letter D. What effect does the tilting of the Earth cause? Yes, letter C, that's correct. It changes the angle then the Sun strikes the Earth and different land areas. Number 8, when it is summer in Southern Hemisphere, which of the following best describes the tilting of the Earth in the Northern Hemisphere? Correct, it's away from the Sun, letter B. Which motion do the arrows in the diagram represent? Correct, it's the Earth's revolution, letter D. The Sun's height is at the maximum when it is directly overhead at solar noon. What do you call the location on Earth where this occurs? Correct, and that is sub-solar point, letter D. Number 11, which of the following best describes solstices? Very good. The point in the orbit of maximum axial tilt toward or away from the Sun. So that's letter D. Let's have number 12. Where would direct rays from the Sun hit in June? Correct. Mostly in the Northern Hemisphere. That's letter B. Number 13. Where would direct rays from the Sun hit in December? Correct. Mostly in the Southern Hemisphere, and that is letter C. Number 14. How long does it take the Earth to complete one revolution around the Sun? Correct. It is 365 days or simply 1 year. It's letter C. 15. What is the Earth's orbit? It is the path upon Earth around the Sun. It's letter A. 1 only. Congratulations for those who got it right. And for your additional activities, we're going to write a poem or a story about the Sun's observed height and its effects on the length of daylight and amount of solar energy on Earth. And here is a rubric for you to follow. So we have 4, 3, 2, 1. Concentrate on number 4. For ideas, grammar, usage and mechanics, and effort. Okay? If there is no question, thank you very much. This is Sir Topper, your Science 7 teacher.